Good afternoon. Good afternoon, everyone. Hope all is well. Everybody's doing all right. So last class we had got into 11.6. So today we'll finish off 11.6, starting off with mutually exclusive events. All right. So if it is impossible for events A and B to occur simultaneously, or if events A and B do not have anything in common, they are considered mutually exclusive. So you see under that, we have or probabilities with mutually exclusive events. And so if we have two events that are mutually exclusive, in other words, they don't have anything in common, we can just add them together, add those individual probabilities together if we want to know the probability of either of those events occurring. All right, can I scroll up some? Anybody on Black still? All right, so first example, if one card is randomly selected from a deck of cards, what is the probability that probability of selecting a king or a queen? All right, so the first thing we want to make sure of is are the events mutually exclusive? And yes, they are, because they do not have any cards in common. So there's no such thing as a king being a queen or a queen being a king. So there are no cards in common. So they are mutually exclusive. All right. So next we will find the probability of each one of them individually. And we've done that before when we dealt with cards initially. Can I scroll up on the green? So there we go. So when we're dealing with our deck of cards, we have 52 cards. So our sample space is 52, number of cards that we have as options. Then the number of kings is 4. The number of queens is 4 as well. So the probability of getting a king and the probability of getting a queen is 4 out of 52. So of course, that they're not going to always be the same when it comes to different events. But when it comes to getting a king out of a 52 card deck and getting a queen out of a 52 card deck, those probabilities are the same. All right. Once again, they are mutually exclusive. And since they are mutually exclusive, we'll add those probabilities together. That'll give us 8 or 52, and then reduce by 4, which would be 2 out of 13. All right. Questions before we go to the next thing? All right, so for probabilities with events that are not mutually exclusive. So similar to what we did when we had mutually exclusive events, but when we have events that are not mutually exclusive, that means they do have something in common. So we have to subtract what they have in common from the addition of the two probabilities. And that's because we don't want to have to count it twice. Or we don't want to make the mistake of counting what they have in common twice. All right. Anybody holding on to purple? All right. So in a group of 22 baboons, 18 enjoy grooming their neighbors, 16 enjoy screeching wildly, while 10 enjoy grooming their neighbors and screeching wildly. If one baboon is selected at random from the group, find the probability that it enjoys grooming its neighbor or screeching wildly. All right, so once again, 25 baboons altogether, 18 enjoy grooming their neighbors, 16 screeches wildly, and then 10 does them both. And we know if we were to pick one randomly, what's the probability that the person, not the person, the baboon enjoys grooming his neighbor or screeching wildly? So first thing we want to do is establish once again, are the events mutually exclusive? They are not, because we have this statement here, this fact that we have a group that enjoys grooming their neighbors and screeching wildly. So that means that's the moment that they both have in common, or the group of baboons that have both of those events in common. So I decided to label G for grooming the neighbors, and then W for screeching wildly. I didn't want to call it S because, you know, S is normally representative of our sample space. So we'll use G for grooming your neighbors, grooming neighbors, and W for screeching wildly. All right. So we can find the individual, find the probability of each individually. So we're looking at grooming. There are 25 baboons altogether, so that's going to be the sample space. 18 enjoyed grooming their neighbors, so that's 18 over 25. For screeching wildly, it was 16 that enjoyed that, so that's 16 over 25. And then for grooming the neighbors and screeching wildly, it was 10 people. I keep saying people, 10 baboons who enjoyed that, so that's 10 over 25. All right. So now we have all three pieces of the formula. So we're going to add our two events together, the probability of our two events together, and then subtract the probability of them occurring with let me say it right, the probability of both of those events occurring at the same time. So 18 plus 16 minus 10, all over 25 gives us 24 over 25. All right, any problems? Everybody done with the red? Okay, so next we have this chart that we will be dependent on. Notice it's the marital status of the US population, ages 15 and older in 2015. And it's in millions. And so question says, if one person is randomly selected from the population represented in the table, find a probability that the person is divorced or male, and then the probability that the person is married or divorced. All right. So looking at the first one, want to find the probability that the person selected is divorced or male. So total number of all of our people is 254. That's going to be our sample space. Now we're looking at divorced. That's this column right here. So total number of people divorced is 26. And then male, total number of males is 123. All right. So also remember, we do need to make sure we have established whether our events are mutually exclusive or not. So these events are not mutually exclusive. A person can be male and divorced. So when we go back to our chart, we can see, right, divorce is this column, male is this row. So right here, this 11 represents the male, the people that are male and divorced. And so that's what's represented in my probability calculations. So once again, sample space is 254 for all three. 26 were divorced, so that's 26 over 254. 123 were male, that's 123 over 254. And then 11 were divorced and male, so it's 11 over 254. All right. Now that we have all three pieces, that's 26 plus 123 minus 11, all over 254. That'll give me 138 over 254. Reduce both top and bottom by 2. And then that'll be 69 over 127. All right, any questions, any questions? Oh, this problem also gave the decimal value. So always make sure you pay attention to math lab and what they're asking of you. If they want the answers in fractional form, make sure you reduce it down as much as possible. But also if they want the decimal value, then you divide it out and round it to the decimal place that they ask of you. All right, everybody good? So the next one, a person is married or divorced. So these events are mutually exclusive. A person cannot be married and divorced at the same time. So despite any definitions we may have of what it means to be married or divorced, if you look at the chart and the way the chart is set up, married is this column, divorced is this column. So there's no interlocking saying that you're married and divorced, either married or divorced. So they are mutually exclusive. Since they're mutually exclusive, we can find the probabilities of each one of them individually and then just add them together. So we already established 254 is the sample space. That's the total number of people possible. Then for married, there were 133 that were married, so 133 over 254. Divorced, there are 26 that were divorced, so 26 over the 254. So once we have both of those, we can just add them together. So it's 133 plus 26 over 254. So it's 159 over 254. And that would be 0.63 if they ask for the decimal. Everybody good? Can we go to the next one? All right. Next, probability of odds. So we have odds in favor of event E. It's going to be the probability of E over the probability of not E, or the probability of event not occurring. Then we have odds against when we take the probability of not E and place it over the probability of E. So it's the same, it's just that you invert the fraction, same numbers. All right, let's try it out. So it says if you roll a single die, find the odds in favor of rolling a 2, find the odds against rolling a 2. All right, so our event is rolling a 2. Sample space is 6. Remember, we talked about rolling a die. And whenever you're rolling a die, you have 6 options, the numbers 1 through 6. And your event, you ask yourself how many different ways can you roll a 2? It's just one time because the number 2 only appears once. So you have the chance of rolling a 2 is 1 out of 6. Now the chances of not rolling a 2 will be everything except for the 2. So you would just take 1 minus the 1/6, and that 1 would turn into 6/6 because of the 6 in our denominator. And then 6 minus 1 is 5. So we got 5 out of 6. Chance of not rolling a 2, 1 out of 6 chance of rolling a 2. Right down with the green. All right. So the first one, odds in favor. Take the probability of your event, place it over the probability of your event not occurring. So that'd be 1/6 divided by 5/6. Now the divisional sign, that divisional bar, the same thing, just one is written vertically, the other one's written horizontally. So I just did that just to show the calculation in the process. Don't forget, whenever you divide it by a fraction, you multiply it by the reciprocal. So that division changed the multiplication, and we flip the 5/6 to 6/5. 6 is canceled, and that leaves us with 1/5. So that's a 1-to-5 ratio. So the odds in favor of rolling a 2 are 1-to-5. 1:5, same thing. B was odds against. So if you already found odds in favor, then really all you're doing is flipping that fraction. But if you had to do the work, that would be 5/6 over 1/6. Those 6's canceled, leaving with just 5/1. So the odds against rolling a 2 are 5-1. And we got one more example under this, and then one more topic, and we'll be done. So everybody keep scrolling up. Okay. So we have the winner of a raffle will receive a new SUV. If 500 raffle tickets were sold and you purchased 10 tickets, what are the odds against you winning the car? Okay, so first thing we want to do is find the probability of winning the car. So our sample space is 500 because there are 500 tickets. We're purchasing 10 of them. So 10 out of 500 is 1 out of 50 when you should simplify the fraction. Then the probability of the event not occurring, or the probability of not winning, will be 1 minus the 1/50. That 1 turns into 50/50 because of the 50 in our denominator. And then 50 minus 1 will be 49 in the numerator over 50. Everybody okay? So we want to find odds against. So in order to find odds against, you will place the probability of not E, or the probability of your event not occurring, over the probability of your event occurring. I won't say occurring. So it'll be 49 over 50 over 1 over 50. Those 50s will cancel, leaving us with 49 over 1. All right. Any questions? Any questions? Almost done. Yeah, here the odds against winning the SUV just be 49 to 1. All right. Last thing we're talking about today, odds to probability. So we're changing odds to probability. If the odds in favor of event E are A to B, then the probability of the event is given by A over A plus B. All right, so the odds in favor of a particular horse winning a race are 2 to 5. What is the probability that this horse will win the race? All right. So odds in favor is 2 to 5. That means A is 2 and B is 5. So to find the probability, that'll be 2 over 2 plus 5, which is 2 over 7. So the probability that this horse will win the race is 2 out of 7. All right. Questions? Any questions? Everybody good? Everybody straight? All right, so that's it for 11.6. We have 5 sections left. That'll be out of chapter 12. So next class, I'll open the floor for questions, see if anybody have any, but we'll go ahead and get rolling into chapter 12. To go ahead and close it out. So then we'll just have, whatever days left to, ask whatever questions you guys want to ask, and then get prepared for our final exam. One of your classmates asked last class, about how we'll be administering the final exam. So we'll all be done virtually. So, you know, I'll give you more information on that as we get closer to it. But, you know, we'll log on to Zoom like you normally would, you know, enable your cameras and all, give you passwords, all that type of stuff. So, but nobody will actually have to come in class, or nobody will come in class to actually administer or take the final exam. All right. So any other questions before I send you out to the weekend? Everybody good? All right. So you guys have a good one. Be safe, and I will see you on Tuesday.